Assalamualaikum and hi, my name is Fathilah Ali and I'm the project leader for polylactic acid Phycocyanin-Alginate composite for cosmetic patch. The research team comprised of Azlin Suhaida Azmi, Hazlin Anwar, Sarah Amalina Adli and Muhammad Sharizat Pairon. Just a slight background on the cosmetic patch, or people call it fondly as a mask. So it comprises of three different components. The first one is matrix, which is the main foundation for a cosmetic patch. So number two is the active ingredient. Here the active ingredient usually a component that possesses a beneficial component for that skin. So number three is the enhancer. So this enhancer is an additional component that can enhance the properties of a patch. Sometimes enhancer can be used, or we also call it as a binder. So by knowing the background of this patch, we can design what kind of cosmetic patch that we want for our future use. So looking on the market demand for a cosmetic patch, we can see there is a huge evolution from 1981 to 2014. I'm sure the demand for the cosmetic patch has been increased tremendously even up to now, because cosmetic patch can be used in a lot for different skins. Okay, can be used for different features on our face, such as nose, lips, for the total face. So we have a face mask by the Mecca Cosmetica. So I am sure that you have been using a face mask before. So there are a lot of companies outside there that has been using a lot of materials as an active ingredient or as a matrix for their product. So another one is for the cold collagen eye patch. Remember, we want to look young. We don't want to. Sometimes we work overnight. We look tired. So people can use this eye patch to look fresh. Okay, so this is a gold collagen eye patch by the Mask World Store. Number three is the anti-aging lip patch by the I Love Makeup. You can see the applications of the patch is tremendous. Okay, if we look at here, it's just in the sense of beautifying. Okay, but we know that as it's a cosmetic, it's for beautifying, but patch can also be used in various other applications, such as also for medical. As can be seen before, we know that there have been a lot of demand on the patches. So a lot of researches has been done in this field. If we can see, there are a lot of matrices that can be used. As an example here, people have been using pectin or chitosan. Okay, it depends on where's the applications to. Therefore, the active ingredients can be changed, such as nicotine or to any essential oils. Okay, so the application also can be varied. Okay, where it can be used in medical or as a cosmetic patches. When we started this project, we had identified a few problems, such as toxic polymers has been used and non-adhesive has been used as a matrix. So here we have proposed solutions, such as we can use a polymer that won't cause irritation to the skin, but on the same time approved by the FDA. So the second one is by using alginate into the matrix, where it can improvise the adhesiveness. So the third problem is the usage of non-degradable polymer. So thus we are going to use a biodegradable polymer to replace the non-degradable polymer that has been used as a matrix in the cosmetic patch. Here people have been using PCl polycaprolactone and polylactic acid as a substitute for the non-degradable polymers as a matrix. For this project, we had chosen polylactic acid. So where it is a very stable and non-reactive, it's easily available and fabricated. It's also a biomaterial and biodegradable. So it has a very good mechanical properties, and it is also a FDA approved material. So for the production, it's a very sustainable. So where it can be produced from the corn, sugarcane, whey biomass or cellulose biomass. So thus the application of the polylactic acid, it can be used in a lot of applications, such as food packaging, biomedical field and automotive parts. The active ingredient that has been used in this project is phycocyanin. So the advantage of the phycocyanin is it's a water soluble, strong fluorescence and has a antioxidant properties. Additional point for this is it is also a FDA approved material. The third component that has been used is alginate as an enhancer or binder. Here, the properties of alginate that is interesting is it's a biodegradable and biocompatible. The second one is it has a very unique colloidal properties where it can help in thickening, stabilizing, or film forming. Know that there are three components, and we had identified that potential materials for that each component. So we know that we are targeting to produce a cosmetic patch. So in order to have an optimized properties of a cosmetic patch, we had outlined our target. So here for the first target, so we have to evaluate the cytotoxicity of a phycocyanin. We have to make sure that it is safe for the usage. Okay, once we have done that, we can go for our second target, which is to select a method. Here actually we have outlined two different methods. Okay, the first one is deep cast and the second one is rollover. So once we have identified which method is suitable, so we can go for the second procedure, which is identifying the right PLA concentration. As I mentioned before, so the matrix is playing a crucial role here because it's going to hold the active compound and enhancer. Okay, so thus the polymer matrix must have a suitable properties such as a good flexibility, or it can hold that both of that remaining materials. So once the second step here, once we had identified the PLA concentration, we can go for the third target, which is optimization of the parameters. So here we had highlighted the three different parameters. So the first one is the stirring time, temperature, and concentrations. So we are going to use one factor at a time method to optimize each of these parameters. So the response for this optimization will be the flexibility, where we can get the elongation at break from the tensile test. Number two is the releasing properties of phycocyanin. Based from there, we can identify the right parameters for our product. As we had set our target, so we had outlined our methodology on achieving each target. So the first one is to evaluate the cytotoxicity. It is very important to know the toxicity of the material being used here, which is the phycocyanin, because phycocyanin is the active ingredient that will be penetrating into our skin, thus making sure it is safe, it can be used. Then only we had gone for the second step. So the second step is on the selecting the right method, which is the deep cast or rollover. Here we found the rollover gave the better properties compared to the deep cast. Once we had identified the method, we had gone to the another step, which is to identify the right concentration of PLA. Remember here the PLA has been used as a matrix. So the matrix is also playing a crucial part because we do not want a material that can be easily torn. So we want a material that has a good flexibility, and on the same time it can hold both the active ingredient and the enhancer. Once we had identified that, the right concentration, we had gone to the third step, which is optimizing the parameters. So we had outlined the three different parameters. The first one is ratio of phycocyanin to alginate. Second one is stirring time, and the third one is the temperature. As mentioned from the step 1, we had chosen the rollover method. So once we had done the film through the rollover, this is the cross-sectional view of that product. So first we have the glass plates. So we will first roll over the PLA layer, right? And then the second layer will be the phyco and alginate layer. Here we had set the thickness of each layer around 0.5 millimeter to 0.5 millimeter. The advantage of this technique is we can use different thickness of each layers. As we had gone through all those three steps, finally we had achieved a homogeneous product. So our final product shows that the raw material that has been used here, the phycocyanin, it gives no cytotoxic effect to the skin cell. So the step number 2, where we had used different methods, here we found that the rollover method gave better properties compared to the deep casting. So PLA concentration at 13 weight percent gave the best properties in terms of flexibility and releasing. So from the third step, we had identified that the phycocyanin-Alginate concentration, which is 40 to 60, prepared at 20 degree for 20 hours, showed potential as a cosmetic patch, as it gave the best properties in terms of flexibility, and it provides the fast release of that active ingredients. I can say that our product features the SDG number 12, where it stands for the responsible consumption and production. So here we have been using a biodegradable polymer to substitute a non-degradable polymer that has been used widely in the market. So it is also environmental friendly by using a biodegradable polymer. So by using this method, it is much cheaper, and it also uh, energy saving. So in that term, we can also save some money. So number 3, our method proves that it can provide a rapid release of active compound when it has been activated. Here when it's we say activated, that means when it has a medium. Okay, here the medium is water. So when you put the water, it has been activated. So when you put on the surface of your skin, it can be released. Not only for this project, even for other projects, we have been very actively participated in local conferences and also international conferences. So we also participated in the university level exhibitions or the national level exhibitions. So even the GRE for this project also won a bronze award under the engineering faculty exhibition. So we also have a few publications. We have a consistent publication in the field of biodegradable polymer, where I'm focusing in the field of polylactic acid. So for this project, we had published the paper in polymers. We also submitted for the patent application. That's all for the product presentation. Thank you very much to the judges, to the committees for giving this opportunity. Looking forward to hear from you. Thank you.